So I want to mention that I discovered that we didn't put our website on this. It's trust.mit.edu. So the last two talks have been, I think, right on, but also disappointing in the sense that they, I don't think, understand what's possible and what's happening. And I hope to sort of inform you a little bit about that, because I think it changes the conversation dramatically. So I got into this 2 decades ago when I was running the first wearables group. So we did smart watches and smart glasses and fashion shows in Paris. Students designed things that looked like, the iPhone. And this is before there was Wi-Fi. This is before there were cell phones, right? And the work, of course, was sponsored by people like Apple and Motorola. So you might sort of guess the Paris design students may have contributed to those. And one of the students went on to become the technical lead for Google Glass. What this experience did, though, is it told us about the amount of personal data that was going to be everywhere, and it was scary. It was also great good you could come from it. Like, for instance, we saw that you could detect when people were getting sick before they were actually really sick. You change your behavior when you're feeling a little off. Could save millions and millions of lives. On the other hand, you know where everybody is all the time and exactly what they're doing. That's really scary. As a consequence, I wrote a paper called New Deal on Data, which started a discussion at Davos more than 10 years ago, and in the hands of Viviane Reding, who's from this area and was Justice Minister of the EU and member of that conversation group, turned into GDPR. In parallel, I began developing technology to be able to deal with the inherent contradictions of all this data. And the discussions that you've just heard are examples of those contradictions. But you don't need to run into them. You can do things really differently, and it's not even expensive. That's what I want to explain to you. So we have this consortium, it's called trust.mit.edu, and over the last 10 years, we've developed a methodology of dealing with data which is inherently more secure, more privacy conscientious, and satisfies the core of GDPR. The key is you don't move data around. If you make copies of data, you lose track of it. It becomes easy to attack. Leave data at its source. Instead, ask questions of data and log those questions, those pre-approved questions, on an immutable ledger like the blockchain or any other sort of consensus ledger. Okay? Now, that to some of you may recognize as what Estonia did, a very poor country around the year 2000. They escaped from Russia. They knew they were going to be attacked. They had IBM mainframes, they had Russian mainframes, they had PCs. They built a layer on top that allowed them to keep data where it was produced and ask questions. They survived a full-on cyber attack by Russia, and they are the best example of the architectures that you need to do. And what we're doing could be looked at as Estonia 2.0. As chair of the big data board for AT&T, I presume you all know AT&T, I can tell you AT&T does this internally so that they never use data illegally. Because in the United States, every state has different permissions. So if you give your permissions in Kentucky, it may not apply in Illinois. So they have to keep the data where it was collected, pass along permissions, and keep a record of everything so that if they're ever challenged, they can go back and prove that they behaved legally. It's not actually that difficult, although it sounds like it might be. Currently, we have a number of industrial sponsors. Intuit, for instance, recently put several million people on their blockchain. They don't like to call it blockchain because it scares people. But basically, they did that so that you could have immutable tax returns, so you could debate this, so you could share data for millions of people. It's using this type of architecture. Ernst & Young is working with the OECD to make withholding for the entire world on a blockchain so that you don't get controversies about your withholding. Those of you who make money in more than one country know what I'm talking about. Other people, like for instance, Digital China, which is a state-owned enterprise, and China Construction Bank are using our systems to redo their financials so that they can move, this is hilarious, they can't move data back and forth to Hong Kong because it's a different government. And I was like, what? Right. The government of France funds us to be able to build national systems in Senegal, Colombia, other places. IBM works with us to be able to do container shipping around the world. Today, not some bullshit tomorrow. Today, millions and millions of tax returns in the US. The OECD one, well, that's beginning. It's not there. Maersk, who's the big container shipper, uses these systems today. Okay? You ought to know this, folks. Last fall, I was invited by the president of the EU, when Estonia took the presidency, to lecture the ministers of the single digital market, all 27 of them, on this topic, so that they knew how to think about these problems in a different way, a way that respected GDPR, a way that respected data localization, because what happens in Germany should stay in Germany, what happens in France should stay in France. How are you going to run a business? I'll tell you. Also, when you don't copy data around and when you keep track of things, you get a level of data transparency and accountability that's dramatically better than you do under today's architectures. It's also much more secure to cyber attack. The basic idea is very simple. Instead of sticking all your data in one spot, which is what as humans we tend to do, you leave the data where it's collected, and you send questions, and these are pre-approved, pre-agreed questions. That's why we call this open algorithms. You can look at the algorithms. You can see what they happen. So if you're a telco, I'm going to send you algorithm 23 on your data, please. And you run that, and then you post the answer on this internal blockchain. I know it's the right algorithm because it's on the blockchain. You can't mess with it. I don't know that you posted the right thing, but by watching you a couple times, I can figure out whether you're lying or not, okay? And now I can go back and audit everything because all of the questions, all of the answers are there to look at. You can do continuous audit. It's no, oh, we discovered they screwed up 5 years ago. No, you discovered today. It also makes security much better because when something begins to change, you can look at it. So you can discover most cyber attacks much more easily. So I hope that understands. You're the telco, you keep your data, you don't share it. I send you a question. A type of question you should pay attention to is aggregate anonymous data. So there's some discussions about anonymization. If you aggregate people, so you never give answers for less than, say, 50 people at a time, or actually the legal standards in Europe run between 15 and 25, but let's say 50 just to be good, and it's anonymous, so that's like, how many people were in this neighborhood at this time? 423. That's not individual level data. It does not reflect on the individual, as long as you don't connect it to lots of other pieces of data like that. So that's like census data. Using these algorithms, you can create what you might think of as rich census systems, systems that pay attention to what's happening in the city, in the country, all the time. And the government of France, the World Bank, and others are funding us to build national data systems to keep track of the Sustainable Development Goals, but also transportation, poverty, disease, things like that, for Colombia and Senegal. And we have one-day auditability of the data systems to ensure that they're fair, that they're doing what they're doing all the stakeholders, the government, the telcos, the NGOs, international, get to monitor the data system continuously at whatever fine grain you want down to the neighborhood level. You can't see individual data. Okay? So you can see this. It's opalproject.org. Look at it, see what you think. There is an additional thing that we do, which it occurred to us after reading all of the things with the U.S. National Security Agency, that if you ever have raw data anywhere, somebody's going to steal it. So not only do you have this notion of you leave data where it is, send questions, but the moment you generate a piece of data, you encrypt it and you never decrypt it again. And I said, well, wait a second, how can you do anything if it's always encrypted? Well, it turns out you can do lots of things on encrypted data that don't threaten individual privacy and are dramatically more secure than the things that you currently do. The head of the UN Secretary General's Big Data Office said, well, I won't tell you the first part. It's sort of like, oh my God, this changes everything. You have to sleep on this because you have notions about data baked into your head so deeply you don't even know they're there, and they're wrong. So here's an example. When you look at people interacting, there's patterns in how people interact. If you're good buddies, you interact a lot, typically out of work. When a fad happens, you see people interacting with each other. Things begin to happen spatially and temporally. Without knowing the data, you can detect fads. You can detect people who are working together. You don't know that they're people. You don't know what they're doing, but you can detect connections. So for instance, here's an example. You can take the Bitcoin blockchain and you can figure out all the people that are collaborating together with just a few minutes without knowing anything about the people, anything about the transactions. It has to do with the pattern of interactions that's logged on this encrypted blockchain. And so if one of those guys in a block turns out to be a fraudster, it turns out they all are. And so you can duplicate the sort of fraud detection stuff that Interpol takes months to do in literally seconds. And you say, well, that's like hard to believe, all that sort of. So I can tell you Walmart, Coke, MasterCard already use this at scale. One of the interesting things about this is that Kai-Fu Lee is wrong about China whooping everybody because it has so much data. These sort of techniques take log of the data that it takes to do normal AI techniques. That means you can detect things quickly. It means you need dramatically, orders of magnitude less data. And the company there is a spin-off that I co-founded. We're democratizing this. We're putting this on the web. So for $100, you can take your encrypted data, so you're not going to reveal it to anybody, and you can do all this fancy AI stuff on it, no PhDs required, and you haven't exposed your data. Go take a look at it. Like I say, it takes days to sort of understand this. So what are some of the things that we've been able to do? So we're doing a big project for Beijing, where we combine all the data from people who hate each other. But remember, we don't have to actually look at their data. We can look at patterns. And what we can figure out is that there's a certain character of diversity in neighborhoods that indicates that they're likely to grow economically. And it's a very strong pattern. So diversity really seems to generate better living conditions. Similarly, when a neighborhood falls in diversity, that's a good predictor of crime. Now, you didn't know that before. And it's because you couldn't look at all that data. Well, we haven't either, but we have been able to analyze the data. Or here's another thing that we did for most of the big cities in the United States. We asked about diversity, but not where people live. We asked what people did. So if it's a store, do diverse people go in there, or only rich people, or only poor people? We're looking at segregation in society. And segregation is the root of this lack of diversity that results in higher crime, it results in polarization. When you have societies living together, they don't talk to each other, it's bad, okay? But it turns out, and this is work with Esteban Moro and Dan Kalachi, that half of the polarization you have in this country and in the US is not just due to systematic things like neighborhood segregation, it's due to your personal daily choices. When you go in a street and you're looking for lunch, do you go in the place that has people like you? Or do you go in a place that has people that are different than you? It turns out half the segregation in this country, like most developed countries, is because you people always go to the restaurant that has people like you. 50% of the polarization in this country and the US is due to those sort of personal choices. Well, that's something you can do something about. So anyway, that's what we're up to. Those of you who are going to Davos, we're going to do a big set of demos at the Tata Dome. That's a picture of the Tata Dome. It's sort of cool. And thank you.